Hello, and welcome to Flying Failures, where we'll be looking at the Pogo Vertical Takeoff and Landing Fighters. Throughout the 1940s and 50s, there was considerable interest in developing vertical takeoff and landing or VTOL aircraft in order to fill the role of a quick-response naval fighter, and with technology being still very much archaic at the time, started a trend of tail-sitting Pogo VTOL fighters, the results of this strange series of models leading to several individual designs that never made it to mass production for a plethora of practical reasons, and today stand as monuments to the limits of aerial technology. Interest in developing VTOL fighters began during the interwar years of the 1930s, as with the rise of aviation over the first quarter of the 20th century, it became rapidly apparent that air supremacy would be a key deciding factor in the success of any tactical campaign in the future. These predictions came to the fore during World War II, wherein the mightiest of the world's battleships and other surface vessels were routed time and again by squadrons of aircraft, which left these technological monstrosities largely defenseless against their airborne foes, and meant severe reappraisals had to be made by the navies of the globe so as to survive aerial bombardments, namely the ability to launch ship-based fighters that could efficiently tackle sluggish dive bombers and heavy bombers. While ship-based fighters did exist at the time, they were generally based on aircraft carriers which, without their aircraft, were easy targets for enemy bombers due to their lack of anti-aircraft guns, while also being resource-heavy due to the fact that they needed a suitable escort fleet to protect them, not only from air attacks, but also submarines and other surface vessels. Ship-based fighters were also present on smaller vessels of the line, down to the level of a destroyer, but these were usually stripped-down variants of land-based fighters, such as the Hawker Hurricane, that had to be launched by a rocket-propelled catapult over the side, but this meant they couldn't be recovered, and therefore had to seek either a land base or aircraft carrier once their mission was completed. Other roles for ship-based aircraft included spotter float planes that were either launched by catapult or craned into the water to perform a regular takeoff, and were used to provide high-altitude reconnaissance when seeking out enemy surface vessels, these planes being very lightly defended and had to be craned back aboard the ship following the completion of their objectives. It was in Nazi Germany, however, where the first flying Pogo design was considered, with Heinkel during late 1944 proposing a tail-sitting fighter aircraft that was to be used not solely in a naval role, but for land-based defense against the Allies, as by this point in the war, most German airfields had succumbed to near-constant air raids by the RAF and US Army Air Force, which meant conventional fighters could not be mustered efficiently to protect the Nazi homeland. Heinkel's engineers in Vienna drafted a design for the Vesper, or Wasp, a Pogo interceptor with a length of 20 foot 4 inches, a tripod tail arrangement with wheels on the tips of the fins, and an annular wing with a small auxiliary flat wing stub, inside of which rotated the propeller, the Vesper's main power plant being the proposed Heinkel SO-21 turboprop, which was derived from the Heinkel SO-11 turbojet that was to be applied to the experimental Messerschmitt P-1101 jet fighter, and was to be armed with twin Mk-108 30mm cannons, and the estimated top speed of the aircraft was approximately 500 miles an hour. The Vesper, however, was a doomed proposal from the very start, as with the SO-11 turbojet never actually reaching production, and with it being found that converting turbine engines into turboprops was not as easy as the designers of the time believed, work on the Vesper was fundamentally altered during early 1945 to create a whole new design dubbed the Lerche or Skylark. This had the same armament and general configuration as the Vesper, but was instead powered by twin Daimler-Benz DB605D water-cooled V12 piston engines mounted in tandem in the fuselage, and driving contra-rotating propellers inside the annular wing. Another major difference between the two models being that the pilot lay prone in the Lerche instead of sitting in a seat as per the Vesper, meaning that the pilot essentially stood straight up when taking off or landing, and thereby allowing him to look down and around more easily, creating what was, for all intents and purposes, an enormous jetpack. The Lerche was also somewhat bigger, with a length of 30 foot 10 inches, but could still attain a top speed of 500 miles an hour, the design of the Lerche eventually reaching the point where a prototype could have been built, but due to the collapse of the Nazi government in the spring of 1945, as the Allied forces advanced into Germany, the scheme could not have been realized. As it turns out, Heinkel were not unique in their proposal, with Focke-Wulf creating their own Pogo concept in the form of the Triebflügel or powered wing, a design that featured 3 straight wings mounted on a rotating ring in the aircraft's midsection, with the pilot being able to rotate the wings so that the ramjets were pointed almost level to the plane of rotation of the wings, and thereby, in principle, allow the aircraft to hover, or he could pivot the ramjets forward to provide thrust for forward flight. Development of the Triebflügel began in September 1944 and was stated to have proposed a top speed of 620 miles an hour, with a rate of climb of 25,000 feet per minute, and the aircraft was to be armed with two MG-151 20mm cannons and two Mk-103 30mm cannons, with the project resulting in the creation of a wind tunnel model, as well as testing for the ramjets being undertaken, although in the end, no Triebflügel prototype was ever completed. In the immediate aftermath of World War II, and with the conflict having demonstrated the importance of air supremacy and the need to have defensive aircraft available at a moment's notice, the VTOL concept continued to be toyed with by the victorious Allies, specifically the United States, with the US Navy becoming interested in the concept of operating aircraft off vessels as small as a frigate instead of aircraft carriers. In 1950, the US Navy outlined a design competition among the main aircraft builders to develop a Pogo VTOL concept, with Convair, Goodyear, Lockheed, Martin and Northrop all submitting designs, with the two finalists selected to build the prototypes being Lockheed and its XFV-1 and Convair with its XFY-1. The Lockheed XFV-1 came first, and comprised a cigar-shaped aircraft with straight tapered wings, plus an X-arrangement tail, with the four tail fins being at 45-degree angles relative to the wings, with small wheels on each of the four tail fins, with the aircraft being powered by an Allison T40 turboprop, which was a twin-pack engine consisting of two T38 turboprop engines coupled together to drive a Curtiss electric culture-rotating propeller system, featuring three paddle blades on each of the two prop stages. The pilot would be sat on an ejection seat that could tilt forward to provide a better view in vertical takeoffs and landings, while control in vertical flight was done by the control surfaces on the tail fin, with the 45-degree configuration being to prevent the tail fins from becoming aerodynamically massed by the wings, with the eventual nickname for the XFV-1 being the Salmon, as a nod to Lockheed test pilot Herman Fish Salmon. The resultant demonstrator was not armed, although planned weaponry would include a pod on each wingtip with twin 20mm cannons, providing it with a total of 4 cannons, despite the fact that due to the unusual wingtip arrangement, the cannons would require a synchronizing gear to allow them to fire through the culture-rotating prop assembly, with wingtip pods carrying a total of 48 unguided rockets also being considered as alternate armament, while the Salmon, while not in use, would be moved about the base on a special trolley that could set the aircraft to the vertical position for takeoff and then, once its mission had been completed, tilt it back to the horizontal. For test flights, though, the XFV-1 was fitted with a fixed landing gear for conventional horizontal takeoffs, as there was uncertainty as to the ability of operating the aircraft vertically until its basic design had been thoroughly tested, a choice that became very apparent once it was found that the XT40-A6 engine, producing 5,850 horsepower, was not powerful enough to support the weight of the XFV-1 in vertical flight, with intentions being to update the aircraft to the XT40-A16 variant with 6,825 horsepower for full flight tests. The first flight of the XFV-1 took place in March 1954, with 27 flights performed during that year, and after 6 months the Salmon was performing horizontal to vertical transitions in flight and vice versa at altitudes of over 1,000 feet, with results from the testing only serving to demonstrate that, even though the transitions could be performed, once the XFV-1 was flying vertically, it became almost impossible to control, tending to stagger around drunkenly while the pilot barely knew if he was rising or falling. Attempts to fit a radar altimeter, which would have helped the pilot with his vertical orientation, were ultimately fruitless due to the inability for Lockheed to develop a unit that was light enough to fit inside the aircraft and not overburden the T-40 engine, which itself was noted for its unreliability. Lockheed's Clarence Kelly Johnson, who had initially praised the Pogo concept, eventually rejected the scheme due to the inherent difficulties of attempting to land the machine essentially backwards, with the pilot not being able to see where they were going, a difficult task on land, but likely near impossible on the open ocean when trying to match the speed of a moving warship, a testament to the fundamental flaws of the Salmon being that no one ever tried taking off or landing it vertically. For Convair and its XFY-1, this had many similarities to the XFV-1 in that it was also powered by the XT40-A16 twin-pack engine and utilized a contra-rotating prop with 3 blades on each stage, although where its differences began came with the model's general configuration, appropriating delta wings, together with both dorsal and ventral tail fins, which were fitted with small caster wheels sticking out from the ends. The Convair's pilot seat was also able to tilt forward, and armament was proposed to be 4 20mm cannons or 48 unguided rockets in wingtip pods, the XFY-1 again requiring the use of a special trolley for ground handling, while the ventral tail fin was trimmed at the tip in order to ease its movement around the base, although it could also, in principle, be jettisoned to permit a belly landing. The problems came in the fact that the ventral fin rendered horizontal takeoff and landing impossible, as had been the case for early tests with the Salmon, and thus evaluations for the XFY-1 had to be done vertically from the very start, a move that was seen as too risky, and therefore required the aircraft to be tether winched to the roof of the gigantic Zeppelin hangar at Moffett Field on the southern shore of San Francisco Bay, with these initial tethered flights, performed by test pilot James F. Skeets Coleman, beginning in April 1954. The use of the Zeppelin shed, christened Hangar 1, was far from ideal for such performance trials, as the confined downwash created turbulence and kicked up dust and debris, while also creating deafening levels of noise, Coleman eventually being able to undertake the first free flight on August 1, 1954, and finally a full VTOL flight on November 2, which included takeoff, transition from vertical to horizontal flight, sustained horizontal flight, and then a vertical landing, though Coleman was not actually able to see where he was going during landing, and thus required the assistance of ground observers to slowly bring the aircraft down. Despite Coleman's achievements, the logistical and technical difficulties experienced by both the XFV-1 and XFY-1 were so great that the US Navy opted to cancel the project. The fundamental principles of creating an aircraft that worked efficiently, let alone performed its role as an effective naval defense fighter, requiring a lightweight machine with copious amounts of power that could only be done through sacrificing fuel capacity and weaponry, with the end result being the scrapping of the project in 1955, and both prototypes for their respective models being sent to museums for static display. Interestingly, while the Navy was undertaking tests with Lockheed and Convair's proposals, the Ryan Aeronautical Company were also developing a jet-powered Pogo fighter dubbed the X-13, which started out as a ground-rig prototype in 1946, christened the Ryan Model 38, with this aircraft being powered by an Allison J-33 turbojet engine and initially operated under remote control, before eventually moving to tethered manned testing and finally a free-flying prototype. However, although the US Navy backed out of the scheme in 1953, the US Air Force soon took it upon themselves to progress the project further, leading to a modified prototype dubbed the Model 69 and a service designation of X-13, with 2 prototypes ultimately being built, which were powered by a non-afterburning Rolls-Royce Avon RA-28 turbojet providing 10,000 pounds thrust, with the resultant X-13 being a stubby aircraft with a high-mounted delta wing, finlets on the wingtips, and a very tall tail fin. This aircraft was much smaller than the Lockheed and Convair Pogos, but with only half the empty weight, with the exhaust for the aircraft being movable to provide vertical pitch and yaw control, while the engine bleed jets in the wingtips provided roll control, and the pilot's seat could be tilted forward to provide a better view in vertical flight. The first prototype took to the air on December 10, 1955, with Ryan test pilot Pete Girard at the controls, the X-13 taking off and landing horizontally using an improvised external frame fitted with landing gear, while subsequent test flights gradually evolved to transitions from horizontal to vertical flight and then back to horizontal, the prototype then being fitted with a wheel tail fixture called the roller skate for vertical takeoff and landing hops, which commenced from May 28, 1956, at which time the second prototype also went into testing and followed the same pattern of evaluation as the first, with the second prototype differing through the use of a slightly modified canopy to provide a better field of view. Unlike Convair and Lockheed, though, the Ryan X-13 utilized an alternative vertical takeoff arrangement, in which the aircraft featured a nose hook and was carried on a special trailer, with the X-13 hauled to the takeoff area, and the pilot would climb aboard while the aircraft was horizontal, prior to it being jacked hydraulically into the vertical position for takeoff, with vertical operations being monitored by a team of ground support crew in the truck that had hauled the X-13, while the nose hook on the aircraft engaged a trapeze that swung out from the top of the erected trailer bed, with the first complete flight using this scheme, from vertical takeoff to horizontal flight to vertical landing, taking place on April 11, 1957. Ultimately, the X-13 proved to be a far smoother and well-organized concept to those proposed by Lockheed and Convair, and soon the test pilots at Ryan became easily acquainted with the vertical takeoff and landing procedure, helped along by the trapeze system. with the Ryan X-13 even being demonstrated above Washington, D.C. during late 1957, although it soon became apparent, as per the previous models, that the aircraft suffered the same need for lightweight and high engine power that had been exhibited with the XFV-1 and XFY-1, meaning that in order to be able to take off at all, the aircraft needed to sacrifice fuel capacity and armament, leading inevitably to the axing of the project in 1958, with both prototypes being put on display in museums. Since the end of the X-13 project, no other attempts at utilizing the Pogo-based VTOL system have come to the same prototype stage as developed in the 1940s and 50s, as under various NATO design specifications, aircraft manufacturers in Europe and America were able to develop a system whereby VTOL models could be derived from more conventional fighter jet underpinnings. This led eventually to the development of the highly successful Hawker-Siddeley P1127 and Kestrel prototypes in the mid to late 1960s that formed the basis of the Hawker-Siddeley Harrier, or better known as the jump jet, the world's first operational ground attack and reconnaissance aircraft with vertical short takeoff and landing or VTOL capabilities, and one which would find use in air forces and navies across the globe thanks to its ability to be operated from improvised or informal airstrips and landing areas. As for Pogo-based VTOL aircraft, proposals were made by various firms to continue development in this particular field, even after the release of the Harrier, with the likes of Steckmer and its C-400 P-1 Attar Volant or Flying Altar, the Focke-Wulf FW-860, the Sukhoi Shkval and the Bell Autonomous Pod Transport or APT, either failing to go beyond the drawing board or reaching the early prototype stage before being ultimately scrapped. Therefore, the idea behind a tail-sitting VTOL fighter was indeed an interesting proposal from the viewpoint of being a technical challenge, but with the move towards drones and other non-manned military aircraft designs, the rise of effective attack helicopters such as the Sikorsky UH-60 Black Hawk and the Westland Lynx, as well as the number of technical sacrifices that had to be made in order to simply allow the likes of the XFV-1, XFY-1 and X-13 to fly, means there's no real possibility of this design configuration becoming a viable alternative to the more conventional layouts as illustrated by the Harrier jump jet.